Okay, guys, welcome. Today we're going to talk about operations with radicals. Now, in the last video, we talked about simplifying radicals, which we're going to need again. So I just wanted to sort of refresh your memory on that. So to simplify a radical, if you have a number at least, what you want to do is you want to write that number inside the radical with one of the numbers being a perfect power of that root. Then once you do that, you'll have a perfect power that you can then simplify, and then you just multiply that by the root of whatever's left. Right? Now, if you have variables, you use the fractional property, right? You convert it to fractional exponent form. You write that fraction as a mixed number, and then you convert back, right? So for example, in part A, we have square root of 27 minus square root of 12. All right, now right now it might not look like we can do much with that, all right? But first what we can do is we can simplify and then do exactly what the directions say. We can combine like terms, right? Now, before we do that, I want to call your attention to part B, actually. So we have 7 square root of 5 plus 4 square root of 3 minus 9 square root of 5. Now, if you were to combine like terms, you would say that these two are your like terms because they both have a square root of 5. So if you were to combine them, that would give you a negative 2 square root of 5 and 4 square root of 3 we can't do anything with, right? And that's how we simplify that sum there, right? Now here we'd have to simplify first. So square root of 27 we could think of as square root of 9 times square root of 3. And square root of 12 we could think of as square root of 4 times square root of 3. Well, this gives us 3 square root of 3 minus 2 square root of 3. So we get square root of 3. Okay, we just did part B. So part C is a cube root of x squared y minus 1/2 square root of xy minus 3 cube root of x squared y plus 4 square root of xy. Now these are nice and simplified already, right? So if we look at our two cube roots, we have a 1 minus 3. So this is going to give us a negative 2 cube root of x squared y. Now if we look at the square root of xy terms, we have a negative 1/2 plus 4. And of course, if we do 4 minus 1/2, find a common denominator, we're really doing 8/2 minus 1/2. So we're going to get a plus 7 over 2 square root of xy. Okay, part D, we have a square root of 125 minus square root of 80. So we need to try and write both of these as the product of a perfect square root and something else, right? So 125 we can think of as 25 and 5. And 80 we can think of as 16 and 5. So we get a 5 square root of 5 minus 4 square root of 5. So this is just 1 square root of 5, which we would just say is square root of 5. Okay. Part E, we have a cube root of 24 minus square root of 8 minus cube root of 81 plus square root of 32. So it looks like for square root of 24, cube root of 24, we could use 8 and 3, since 8 is a perfect cube. 8 and 3, not 8 and 8. And that would give me a 2 cube root of 3. For 8, for square root, we can think of that as square root of 4 times square root of 2. So that would give us a minus 2 square root of 2. For the cube root of 81, we could think of that as cube root of 27 times cube root of 3. So that is a 3 cube root of 3. And finally, for 32, we could think of that as a 16 and a 2. So we're going to get a plus 4 square root of 2. So when we combine all these, our cube roots give us a minus cube root of 3. And my square roots will give me a plus 2 square root of 2. Okay. And yes, there was a part F. So part F, we have a 2 times a fifth root of xy to the third, 4 times a fifth root of x to the third y, minus 5 times a fifth root of xy to the third, minus a 2 fifth root of x to the third y. Okay, now here you just have to be careful, right? So it looks like my x, y to the third terms are these two, and then my x to the third y terms are these two. So it looks like when we combine, we're going to get a negative 3 fifth root of xy to the third minus a 6 fifth root of x to the third y. Okay, so hopefully those aren't too bad. Now let's do some where we have to multiply, right? So essentially what you're going to do to multiply these things is you're going to separate, so separate, and then use, actually we don't even need to separate. All right, let's make it easy on ourselves. You're just going to use this property, right? If you have the product of two of the same type of root, you're just going to take the root of that product. Yep. So here for part A, we have 2 cube root of xy squared times the cube root of x squared y squared. So what I can do here sort of in slow motion is I'm taking the cube root of xy squared and I'm multiplying that by x squared y squared. So I'm going to get a 2 times the cube root of now x to the third y to the fourth once I combine those inside numbers. Now, if we now separate, I should have said that before. Now we separate to simplify. So we're going to get 3 over 3 and a 4 over 3 for x and y. So we get a 2x y to the 1 1/3. So we get a 2xy cube root of y. Okay. Part B, we have a square root of 3 plus 2 times the square root of 3 minus 2. So now this is just FOIL. If we do square root of 3 times square root of 3, we get a square root of 9, which is just 3. Then we'll get a minus 2 square root of 3 plus 2 square root of 3, so they cancel. And then we get minus 4. So we're going to get 3 minus 4, which is a negative 1. Okay, and now we can sort of use a similar trick for part C. This was part B, sorry. Part C, we have a square root of 2 minus square root of 5 times the square root of 2 plus square root of 5. And if we FOIL here, we're going to get a square root of 2 times square root of 2 is 2. And then a square root of 2 times positive 5 is a plus square root of 10. Minus square root of 5 times 2 is minus square root of 10, so they cancel. And then we get a minus 5, so negative 3. Okay, and then for part D, we have a 2 square root of x plus 3 square root of y squared. Now here, we can use the property that if I have a plus b squared, that's a squared plus 2ab plus b squared. Right, and of course, if not, you could just write it twice in FOIL, but I'm going to use this special property. So we could say this is 2 square root of x squared plus 2 times 2 square root of x, 3 square root of y, right? I'm just taking 2 times the product of each of those things, and then plus a 3 square root of y squared. So I'm going to get a 4x, right? If I square 2, I get a 4. If I square root of x, I get an x. And then 2 times 2 times 3 will give me a 12 square root of xy. And then I'm going to get a 9y. Okay, so that's that one. Now, in the previous example, we looked at a few examples where we had square root of m plus n times square root of m minus n, just gave you m minus n, right? So this is sort of a clever trick to eliminate any radicals, right? So if you have something like a denominator where you have more than one radical term, what we can do is we can multiply by square root of 5 plus square root of 2 on the top and the bottom, right? And this trick is sort of, this thing is referred to as the conjugate of square root of 5 minus 2. Basically, what we mean when we say a conjugate is that you are multiplying by essentially the same thing, except you're changing the sign, right? And the reason why we do this is because the bottom will now just become, what's the first term squared? It's 5. What's the second term squared? It's 2, and put a minus in between, because it's like your difference of two squares, but with just square roots. So now the top is going to become a 4 square root of 5 minus 4 square root of 2, and the bottom is just 3 now, right? So this is 4 square root of 5. Let me actually just write this on a new line. So we get 4 square root of 5 minus 4 square root of 2 over 3. All right, so that's part A. For part B, we have a 5 over square root of x plus 2. So using this conjugate trick again, we're going to multiply top and bottom by square root of x minus 2. So in the top, we're going to get a 5 square root of x minus 10. And in the bottom, we're going to get an x minus 4. Right? And we can actually leave this just like this. Okay, in part C, we have a negative 1 over a 2 minus square root of 3y. So here, using the same trick, we'll multiply by 2 plus square root of 3y. So on the top, I'm going to get a negative 2 minus square root of 3 times y, right? Make sure that you're distributing that negative there. And then here, we'll get first term squared is 4. Second term squared is a 3y. And this one we can also leave like this. And then finally, part D, we have a minus 6 over square root of 2 plus square root of 6. So we'll multiply the top and the bottom by square root of 2 minus square root of 6. So in the bottom, we get a 2 minus 6. And in the top, we get a minus 6 square root of 2 plus 6 square root of 6. And so we're going to get a minus 6 square root of 2 plus 6 square root of 6 over negative 4. So it looks like finally we can say this is 3 over 2 square root of 2 minus 3 over 2 square root of 6. Okay, so that's our final answer there. All right, so that concludes this video on operations with radicals. I hope you enjoyed, and I will see you next time.